Hi team, thanks for joining. Yeah, do you guys have any update about Veda? Actually, she is supposed to join the class, right? Okay, let's quickly give one more minute for her to join. Perfect. I've also joined. Yeah. Hi Veda, we are waiting for you. Um, okay. Before starting anything, so have you gone through yesterday's PDF, yesterday's class? What we discussed yesterday? Can anyone let me know? Hello. Yesterday we discussed, right, what we again discussed on RDD, what is RDD, right? How we are going to do step-by-step processing, data partitioning. We discussed, right, what is a transformation, what is lazy evolution. We discussed it yesterday. Can anyone let me know what is lazy evolution? Arun? Yeah, yeah, Karthik. Come on, Karthik.
Leche evaluation, right? Sir?
Yeah, lazy evolution.
Uh, Leche evaluation is a uh, transformation some others
Transformation.
on RDDs.
Okay. Seems Karthik lost. Okay. Mm, Arun, Deepti, Veda, anyone? What is lazy evolution?
Evolution means that the transformation data are not executed immediately.
Sorry, transformation?
Transformations on data are not executed immediately, sir.
Not executed immediately. Exactly. So when they will get executed?
When action is called.
Exactly. When action is called, transformations will get executed. Why? Because it won't keep the data ready until unless an action is called. We won't keep pizza ready if there is no order, right? So that was example we discussed yesterday. Okay. So what is partitioning in Spark? We discussed, right? What is partitioning? Anyone? What is partitioning?
Partitioning is
Hmm.
dividing a data
Dividing data into
uh, multiple subgroup.
multiple parts. So each partition will be given into each partition will be given into one of the executed task. Okay. So now this executed task can work on these partitions, right? That's what we discussed yesterday. Okay. Now today we are supposed to discuss on wider transformation and narrow transformation. Does anyone gone through that wider transformation and narrow transformation? If so, just let me know. No one?
Narrow transformation,
Hmm.
no shuffle.
No
Like
shuffle.
data
Hmm.
stays in partition. Then in wide transformation,
Hmm.
data moves across partition. So
Partitions.
shuffle required.
Yeah, shuffle required. Yeah, good. That's the exact meaning between this narrow and wider transformation. So you need to understand this difference very well. You might get answers on top of this. Okay. So yeah, but today we will start with that narrow and wider transformation. Transformation we know, right? Yesterday I show you an example, like full name example, right? You wanted to see. Is this okay? So this is the is this not this one? Yeah, this is the one, right? Yesterday I show you this, right? Small example. What is transformation? How transformation looks like? Like before transformation, this is an RTD. After transformation, this is RTD. So what was the transformation we applied here? We applied some transformation on top of this RTD, so that's why we got RTD2. We discussed, right? RTD. If you apply any transformation on an RTD, it's going to create new RTD, right? So what was the transformation we applied here? This is the transformation we applied here, okay? So combine both first name and last name. That is the transformation we applied. So this is the code, okay? This is the code, data dot with column. Actually, we call it as a data frame, okay? Data frame dot with column, full name and concat of first name, comma last name, okay? Code it. This is the code, okay? It won't do anything unless any action is called. Can anyone let me know what is action here? What is action in this code snippet? Okay, so out of this, these are the two lines of code, right? Two lines of code, very simple. So what is the action here? What is the transformation here in this both? Right? Just let me know. This is line one, line two. So what is transformation here? What is action here? Which line indicates transformation? Which line indicates action?
First line transformation, sir.
Okay,
Second line evaluation.
evaluation, th- not evaluation. This is action actually. This is the action that will trigger this transformation. Okay, because we discussed this transformation will never get. It won't do anything. It won't get executed. Okay, this thing won't get executed unless any action is called. Okay, so data dot show small action. That means lazy evaluation. It will trigger the lazy evaluation because unless this data dot show is called data frame dot show, nothing will happen, right? Nothing will happen. So that's why this is what action, and this action is going to trigger this transformation. That's what we discussed yesterday, right? Now, now let's discuss on the narrow and wider transformations. So what is narrow transformation? What is wider transformation? As Veda properly said, wider transformation means the data will get shuffled between the partitions. Okay, narrow transformation means data won't get shuffled between the partitions. Okay, let's try to go with some normal example. Okay, um, let's say you are four people, right? Currently, okay, one, two, three, four, four people. Okay, so what I will do is I will give you the book, okay, a book, okay, and I will ask you to count number of words in that book. Okay, now you will take that book, okay, you will count number of words in your book and you will just give the data to me, right? You will do it yourself, right? You do not need anyone's help. You can do it on your own self, right? But if I give the books to you, number of multiple books to you, let's say uh, each one 10 books. Okay, that means 40 books I will give among, I will distribute 40 books among yourself. Now I wanted to know, for each author, right? You know, right, a book is created by an author, right? For each author, how many words? Okay, let's say there are two authors or four or five, I'm not sure, but I will give you 40 books to you. I will distribute 40 books among yourself. Okay, now I will ask you to count number of books that an author has written out of these 40 books. Okay, how will you do? You'll have, there is no guarantee, right? You will get all the same, all the books of the same author, right? You might get a book for author A, and someone will get, Anusha will get a book of author B, right? Again she will get author A's book as well. She will get a book for author C as well. Okay, similarly the other three persons will also get different authors. Now you need to separate these books. You need to shuffle these books among yourself, right? Shuffle in the sense, data movement, right? You need to move this data among yourself, books among yourself, and see, uh, to make sure that the same author books will belong, come and sit into one person. Okay, let's say Anusha is working on author B, then Anusha will make sure that all books, all books, all books related to the author will come to her, so that she can start to work. She can count number of books that this author has written. Okay, so similarly, just give me a second. So similarly, you other guys, right? So you will also get some books from for you, right? Some other, right? You hope you guys are getting. So you have 40 books. 40 books are written by five different authors. Okay. So these 40 books I will distribute among yourself. Okay. I will distribute randomly. Okay. So that each person will get different author's book. Okay. Now my query is, I need to count number of books that an author has written. Okay. Now what you need to do, you get your, let's say, Karthik will get a book for author A, author B, author C, author D. Okay, now Anusha will also get similar way, and everyone will get similar way. They won't get the books of, it's highly high chances, right? There are very zero chances that you are going to get the same author's book. Now you need to distribute your books among yourself, right? So that's what data shuffling is in the real world. Okay, so wider transformation means the transformations will have input data from the multiple partition, right? This typically involves shuffling. We just discussed shuffling. You need to distribute, you need to shuffle these books among yourself, so that you can count number of books another has written. Right? You need to shuffle data across multiple partitions. Okay, then you will find the answer and you will give that to you. So without shuffling, you can never calculate number of books another has written. Right? You got the whole point, right? Okay. So what is narrow transformation? What is wider transformation? Can anyone explain me? Very simple. Whether you already know, so others, right? Anyone? Karthik, Karun, and Deepti. Yeah. What is wider transformation? What is narrow transformation? Yeah.
Yeah, data will not shuffle between the partition in arrow
Data will
transformation.
not shuffle within the partition. Okay.
Data will shuffle between the partition in byte transformation.
While doing transformation, data will shuffle between the partition. So okay,
Yes.
what is the transformation? What is the transformation called? Wider transformation or narrow transformation?
A wider
Narrow,
transformation.
narrow.
Narrow means
No,
Data
no data shuffling, sir.
no data shuffling. Yeah. Wider
Uh,
means
white,
hmm.
data shuffling means white transformation.
Wider transformation. Perfect.
Right?
Okay. Okay. Hope you guys clear, right? So just try to explain the in data way. If you want to try to explain in the data way, you what you will say is, okay, there are five partitions. Okay. If my transformations requires no data shuffling, okay, no data shuffling, then I'm going to perform narrow transformations on top of this data. Okay. Otherwise, if I need to shuffle the data, then the transformation I do on top of that shuffle data, right? That is a white data transformation. Okay, very simple. Just keep it that simple. Okay, so we'll just go through this document again. Transformation in Spark. A transformation is an operation applied on an RDD or data frame or data set to create a new RDD. Right? We already saw this, right? RDD plus transformation is going to create a new RDD, and transformation we just logic, right? Some code we saw yesterday. Okay. Now this transformation is divided into two types, narrow and wide. Okay. In narrow transformation, in these transformations, all elements that are required to compute the records in a single partition live in the same partition of the parent RDD, right? There is no data shuffle. Like you wanted to apply some transformation, and for that transformations, if you wanted to run any transformation on top of the data, there is no need to shuffle across the partition. Data don't need to be shuffled across the partition. You can apply these transformations on top of the data. That's it. Very simple. Okay. So the small examples are map. Okay. So as you guys, if you guys started practicing on this Python, then you will get to know these things easy. Map, okay. Filter is also very easy, so you'll get to know. Create a new RDD by selecting only the elements of the original RDD that pass a function's condition. How to explain you? So have you guys started working on Python? What is map in Python? Anyone let me know. So wait. Before showing any practical, let me give you some. Python has some function. Okay, map. I'm going with Python only. Map. Map of list 1 comma what I can say, list 1 is equal to 1 comma 2, list 2 is equal to map 1 of list 1 comma let's map let's map some list 1 of 2 comma, let's use some logic. Addition at function. Then this map will do addition. Map will take this as input and it will do square, let's say square function. Okay. What do we do? Map. Okay, so how I can explain is, okay, so what happens in the map is, okay, let's think this is a map. Okay, you have list 1 and 2. Okay, 1 comma 2. Okay, I need to apply square square to every number. Okay, that means let's take this. Okay, now square of every two number is, that means it will become 1 only, this will become 4. This is the output I wanted to see, right? This is the output I wanted to see. Okay, now what I'm doing, I'm creating a list 1. Okay, list 1 is equal to 1 comma 2. Fine. Now list 2, right? List 2 or whatever, maybe you can just take this and just map this 1 comma 2 for this list. Okay, list comma square. Okay, then what happens here is, I forgot the syntax here, exact syntax, but what happens is this square, right? What it will do is, it will take the first element. Okay, first element, it will pass it to this square function, and it will give the output as, for 1, it will give output as 1 star 1 1. Okay, now 2, it will take the output 2 star 2 as 4. Okay, this square function will do that. It will map this map. What it will do is, it will map this square function to every element here. So in that way, this 1 becomes 1 and 2 becomes 4. Now this is your final list. Okay, 1 comma 4. Now this is the output you're looking for. Similarly, now let's think in this way. You have so much amount of data, right? So much amount of data, you have multiple partitions. Now all you need to do is just go to that, how to put it in this way is, let's say this 1 comma 2 comma 3 is one partition. Okay, home partition 1 p1. Okay, 2 comma 3 comma 4 is p2. Okay, now I want to unmute yourself. Okay, then please be involved here. Okay, see, these are the three partitions we have in our data. Okay, now I'm just applying this function on top of this. Okay, and for your information, this is partitions, but how this partition looks like is 1 comma 2 comma 3 comma 2 comma 3 comma 4 comma 4 comma 5 comma 6. So this is the one partition, sorry, one data set we read, right? This is the data set we read. Okay, and we have three executors. Okay, three executors. Three executors means you will divide your data set into three parts. right? That's what I did here. Three parts in the sense three partitions. Okay, partitions. Now this is partition 1, partition 2, partition 3. Now I'm applying mapping, map on top of this. Let's say this data set, right? I will call as a dummy, dummy data set. Okay. Now on top of this data set, what I will do, I will take this data, I will dummy data set and push this square function. Okay, square function. So far clear? I want you to unmute yourself so you can involve in this class. Okay. So far clear?
Yes, yes.
We have this data, dummy data set. Okay. Any data set. Let's go with COVID data set. Something, anything, some name, random name. That's it. Okay. Take this data set. Okay. Now this data set, right? We have 1, 2, 3, 2, 3, 4, 4, 5, 6. Okay. Now you will take this data set and do the partitions. That's what we discussed, right? First thing we are going to do whenever you read the data is Spark will do the partitions, right? Spark will do the partition. Now Spark did the partition and you got the three partitions. Okay. This is partition 1, partition 2, partition 3. Okay. Now I'm applying mapping. So this is a transformation. Okay. Transformation. Okay, this is a transformation. I'm uploading transformation on top of this. Okay, now what happens here? I just want you to unmute yourself. So I think there are four people, right?
Yes,
Four
yes,
people.
yes.
Okay, so I will give you one more partition here. Before to create a partition, I need to know have the data, right? 5 comma 6 comma 7. I'll create one more partition. I want everyone to explain how the mapping works here. Okay. No, anyone who wanted to go first? But we will apply partitions on top of this. Sorry, transformation on top of this partition, right? Now each will happen in the parallel, right? Parallel. I do not want to put this into same. Okay, parallel. Each execution will happen in the parallel, right? That's what we discussed. Parallel, because that's why we are doing this, right? So there are four people, okay, that are working on this partition. So that we have four partitions. Okay, what if you have eight partitions? That means it will go into the batch. Okay, if you have eight partitions, there are only four people to execute the task. So in the first place, they will process the first partition. Then they will go to the partition 5, 6, 7, 8. Okay, again, each executor will get two partitions. Okay, fine. Now this is the first partition. We are going in the parallel, right? Now who want to go first? Okay, let's say this partition belongs to Veda. Veda, can I know what is the output of your partition? Come on, you can unmute yourself. So this is your partition and we are applying this mapping on your top of your partition. So what is the output we will get?
Um,
Square we are applying. So what is the output you will get?
1,
1,
4,
4,
6, sorry, 9.
9. Perfect. So Veda has done his product. Now at the same time, the other guys will also do their partitioning. Okay, their process, their transformation, which we gave them. Right. Now so Karthik will come here and say 4, comma 9, comma 16. At the same time, while Veda is telling these numbers, right, Karthik might have already calculated this partition too, and Arun might have calculated these values, and Deepthi might have calculated these values, right? You've done in the parallel, right? You're not doing one by one. Maybe Veda spoke first, but you already did the calculation in your mind, right? So that's how these things work in real time. Okay, but Veda, when you are answering this question, right? So do you require the data from the other data sets, other partitions? Do you need the data? No, right? Because you're
No.
just doing the mapping. Because you have a partition and you're just going with simple map function. And map function, you don't need to go to the other partitions and see what's happening there. Okay, fine, perfect. Now let's go with one more example. Okay, I wanted to count number of alphabets here. Okay, this is my data set. Okay, now I want everyone to unmute yourself and say the answers at the same time. Okay, then I will see how things work. Okay, so A comma B comma C comma B comma C comma D comma A comma B comma C comma D comma E comma let's go with ABC only. AB, comma, E, comma, D. Perfect. Okay. Now let's make it into four partitions. Okay. This is partition one. Okay. P1. P1 belongs to Veda. Okay. Now BCD belongs to P2. P2 belongs to Karthik. Okay. So BCD, ABC. Okay. Um, P3 belongs to Deepthi, ABC. Okay. This is the partition. Now DABCD. Okay. So somehow you got this partition. Okay. Let's remove this CD. DAB. Okay. Who's that next guy? Arun. Right. P4. Okay. Now this is the partition. Mhm. P4. Okay. Now I want you to calculate number of A's. Okay. Veda, your task is to calculate A's, and Karthik, you need to calculate number of B's. Okay. You want to calculate number of C's, Deepthi, and Arun, you want to calculate number of D's. Okay, perfect. This is the task I was giving to you. I mean, just think this is your data. Okay, till here on the data, but this is the task I just gave you, so that you will understand how things work in the real time. Okay. Now that's what we call as a group by. Okay. By the way, group by alphabet. This is how we write group by alphabet. Okay, group by alphabet. Okay, now this is what you need to do: group by A, B, C, D, and you all will calculate these things and give the output as to me. Okay, fine. Now come on, whether you need to calculate how many A's here. Okay, come on, whether you can unmute yourself.
One.
One. You have only one, so now you will say A is one. But now let me know, do you have any A's in the next three partitions? Do you have any A's with your friends?
Yes. In
Yes.
Deepthi, I have one, and in Arun, I have one more.
Yeah, in Deepti's partition you have one, and Arun's partition you have one. That means this data needs to shuffle, right? This data needs to shuffle to you, right? Now,
Yes.
after shuffling, okay, after shuffling, this P1, partition one will become for Veda A, comma, you brought it from, you have already have one A, and next A is from Deepti, right? From Deepti you will get
Yes.
A, and from Arun you will get A.
Arun, I'll get one.
Okay, then you can calculate there are three A's.
Mm.
Right? Now you can conclude that there are three A's. Perfect. Your task is done. Now let's come to Karthik. Karthik, you need to calculate B's. How you will do that?
Uh, I have before shuffling, I have one B.
One. Okay.
So after shuffling, I have four Bs. I have
Four B's.
Vedavan and
So
Deeptivan around.
yeah, you need one from Veda and Deepti and Karthik. Right? Four B's.
Yes.
Now you need to shuffle. Right? Without shuffling, you cannot. In your partition, you do not have any data. So you need to shuffle the data. Then only you will have this values. Right? Perfect.
Yes.
Now who's next? Deepti. Deepti, right? Yeah.
Yeah, before shuffling it's one.
Okay.
After shuffling it's three from Vida and Karthik.
Yeah.
Thank
So
you.
Veda partition and Karthik partition, you need to shuffle the data, right? You need to shuffle data from there, and then um, you will have three. You can conclude that there are three C's for you. Okay. Now, who is that finally? Karthik. Now, Karthik, how will you do that?
That's it.
Yeah, Karthik, you need to calculate number of B's. How will you do that?
Uh, Arun have one,
Arun have one. Arun's partition will have one. Okay.
one and Karthik have one.
Karthik has one. Okay, there are only
Yes.
two D's.
Yes. Yes.
Okay, fine. That means we have two D's.
Yes. Yes.
Okay, 2 days, right? Perfect. This is how this works in the real time. Okay, this is how the shuffling works. Okay, that means each partition, let's say in the above, right? If here this partition, right? You don't need to swap the data. Have you observed that? Right? When I asked whether about this partition, she mentioned, right, 149 without checking for the other table, other partition. right? But now when I asked Veda, she mentioned that she need an A from Deepthi and A from Arun, right? That means she needs other data, other partitions data, so that she can complete the processing, right? If you observe clearly, this is what happens in the real time. Okay, the data don't need to be partitioned, I mean shuffled among the partitions. You can just calculate the partition you have, that's it. But here in the group by, right, you need to get the data from the other partitions, then only you can calculate the results, right? That is what this wider transformation and narrow transformation looks like. Okay, now tell me, out of these two transformations, this group by and mapping, which is wider and which is narrower? Out of these two transformations, what are the transformations we did here? One is group by, one is mapping, right?
Yes, yes.
Okay, out of these two, which
Yes.
is wider, which is narrow?
Mm,
Mapping is one transformation, transformation one. Okay, now second one is group by. These are the transformations we did. Now I want you to answer what mapping belongs to which transformation. Is it wider or narrow? Anyone? Answer.
It's narrow
Narrow. Why narrow?
because data will not shuffle.
Data is not shuffled. So when I ask you the answer, you mentioned without checking for the others data. Now group by, is it narrow or wider?
Wider.
wider, sir.
Why
Wider. Why? Why wider?
shuffling?
It's shuffling is
Shuffle.
Shuffling has happened, right? You need to get other partitions data, you need to read other partitions data, then you need to calculate your values, right? So that's what this mapping and group by will do. So now you already know this example, right? What is mapping, right? You already know how mapping works in the real time. Okay, now you already know how group by will works in the real time. Okay, reduced by is also similar kind, similar to group by. It's just that group by, what happens is it will first shuffle data and then do the calculation. Now reduced by key is it first calculates the data, I mean that means a1 in one partition and a2 in one partition, a3 in one partition. It will do the local aggregation, then it will shuffle the partition. Okay, shuffle the data among themselves. Okay, just simple. And joining means, okay, joining means I'll dedicate a single class to this for joining itself, okay, so that you will understand what is a joining. Okay, now filter. Filter select creates an new RDD by selecting only the elements of the original RDD that passes a function's condition. Okay, filtering. Okay, let's go with the filtering. Now hope you guys understand, right, what is narrow and what is wider, I hope. Okay, if Anusha is also there, let's say Anusha is also there, and I will give Anusha the task that, okay, Anusha, let's calculate number of E's. Okay, now Anusha will go and see here. Does this partition has any E? Does Anusha have any E? Let's say P5, right? P5. Anusha has, let's say, B comma A comma B comma E comma E. Now Anusha will come here and Anusha will check how many E's she has. She has only one E. Okay, one E, and secondly two E's she has. Okay, and she will go and check whether do you have any E's. Karthik, do you have any E's? And Deepthi and Arun, same. She will check with all for partitions. As they do not have any E's, Anusha will conclude that there are only two E's. Okay, now there are only two E's. That's what Anusha will conclude, right? That's how this works. She is checking for the others partitions data, but there is no data. That's why she is not doing any shuffling. Okay, but she is checking, right? She is at least checking. The data may not be shuffled, but she is trying to check that. Right? She is checking at least. Okay, fine. This is mapping and grouping. You already understand. Okay, now let's come to filter. Filter means filter means okay. So filter in the sense, you know, filter, right? Filter means you need to eliminate something. Okay, some condition. Okay, where I need to have filter means I need alphabets till D. Let's go with C. Till C. Okay, that means you can have A, comma B, comma C in your output. Okay, maybe let me put it in this way, till 5. That means you can have 1, comma 2, comma 3, comma 4, comma 5. Right? Filter. I need numbers. Okay, any number after 5, I won't do it. Okay, now let me build the partitions for you again. Okay, you are understanding, right? Any doubts so far?
no doubts, sir.
Okay. If we take this, replace b with 1. Okay, replace a with 11, c with 2, replace all, d with 22, replace all, b with 5, replace all. Okay, so these are the partitions here. Okay, it replaces this as well. Super. That's how this thing happens. Fine. This is Karthik. This is Anisha. Okay, these are the partitions we have. Okay. Okay, these are the partitions we have. Okay, partition 1, partition 2, and partition 3. Okay, now I need to do filtering. Filtering, okay. So filtering on top of that, okay, I need output of 1, 2, 3, 4, 1. The number shouldn't be, I need number till 5 only. Okay, till 5 only. After that, any number come, I want to. Now, let's go with Karthik's first. Okay, so Karthik, what is the output of your partition? I need to filter the numbers and see only the numbers that are less than 5. Come on,
I see. Um,
come on. So is one greater than 5 or less than 5?
Less than 5.
Okay, less than 5.
So
1 will be the output. Then next one,
1.
1. Next 11,
No, sir.
no.
So
Perfect.
because greater than.
Your task is completed, right? Now Deepti will
Yes.
come and say there is, let's say, the 2 comma 22. Okay, in her partitioning. Okay, then what she will come and do? Um, Out of these partitions, only 2 is less than 5, right? Okay. Now Arun, right? Arun will come and say that Arun will come and say that this partition there is nothing, empty. Okay. Now Anusha. Anusha is not in the class, but Anusha comes and say that okay, I have 5. Right. Now you guys are doing something here, some transformation. You just filtering that number less than or equal to 5. That's the filter we applied here, right? Filtering. Right? You understand what is filtering? Filtering means where maybe is in SQL where student ID, sorry, employee ID greater than this so and so, employee salary greater than 10,000, something like that. Those are the filters, right? So similarly here the filter is number less than 5. Okay, number less than or equal to 5. That means 1, 2, 3, 5. If I have any numbers of this 1, 2, 3, 4, 5, I will put it in output. Any numbers that are greater than this, I won't put that in the output, right? So now Karthik comes and apply this transformation. To apply this transformation, you do not need to go to other partition and see. There is no need, right? When I asked Karthik about okay, Karthik, what is the output of your partition? He said just 1. He don't need to go and check here whether there is anything that is greater than 5 less than 5. No, he do not bother about those things because filter is narrow transformation. You don't need to shuffle data with the other partitions. That's it. Now I will combine all this 1, 2, 5 and give output as 1, comma 2, comma 5. That's it. This is the final output. Right? Final output 1, 2, 5. That's it. Very simple. Right? Otherwise, let's say if you wanted to count number of ones, okay, count something or you need to group by, then Karthik might have gone to Deepti and asked Arun and Anusha for what are the numbers they have. But we are not doing something like that, right? We are just doing filtering. That's it. That's why filter creates an RDD by selecting only the elements of the original RDD that passes a function's condition. Okay, that's what they will do. Flat map, to explain flat map. For now, you can understand map only. Flat map means the structure. If in the map, right, it's a bit difficult for you at this early stage. Okay, so if I explain the map, right, if I give any condition, right, if I give, let's say, and give a small sample, that's it. But one in the coming classes, we can discuss. Right, this is a nested. Okay, 1 comma 2. Okay, simple. If I pass this into map of this, let's say this one. Okay, so this will give output as, let's say, square again. I will pass the square again. Okay, now this will give output as, okay, 1 comma. Now anyone let me know what is output here? Come on.
1, 4.
1 comma 4. Perfect. Now you are good. Now, if I pass the same thing into flat map, okay, okay. Now, can anyone let me know what is output here? Flat
1
map.
comma 4.
Sorry.
1 comma 4.
Okay. Do I need to put brackets here or not?
Not.
Sorry.
No,
You
sir. No.
have to put
Put
Or not. Okay. Now that's the question, right? That's where this flat map will come into the picture. Flat map means you don't need to have the same structure. You do not need to put the brackets here because flat map. If you insert any list, sorry, any structure to map, okay. If you pass any structure to map, that structure is retained. Okay. In case of flat map, it won't be retained. That's what flat means. Okay, you're just flattening the structure, is not retained. Okay. Now, Arun, you are saying that, right? You need to put this squares brackets here, but no, we are not going to put that because the flat map, right? The structure is not retained. Any elements you just pass it to is, it will be flattened. It will be flattened. Okay, you will just one after one element. That's it. This here in this list, I'm just passing a tuple. But if you see, enter numbers are out of the tuple, right? There is no tuple, nothing. Just list. That's it. Right? That's what flat map. Okay. So that's why in the flat map is also a narrow transformation. Okay. Maybe a bit confusing for you, but in the coming classes you can understand. Okay. Now what is sample? Sample means if I go with this data frame, right? Um, okay. So where is the partitions we created? Okay. So this is the partitions, right? Now we'll take this. Okay. So far clear, no doubts, right? Hopefully. Okay. Now I just taking data frame dot sample. Okay. Data frame sample. Okay. Now that means sample of something. Just for now understand sample. That's it. Okay. Just give half of the data sample because in the real time production, right? Production will have very huge number of data. But I want to do some transformations in that. Then what I will do is I won't take the entire data. I will take only small amount of data, small fraction, right? You don't need because whenever you go to any rice mill or something, right, you won't check the entire data, right? You'll just take sample and check, okay, if the quality is good, then you'll take that packet, that rice packet. Similarly, here you will check small amount of data. Let's say 0.25. 0.25 means half of, I mean 1/4 of data. Okay. Now, let's say half. Let's go with half. Okay. 0.5. What happens is, let's take these partitions. Okay. Now when I ask for 0.5 partition, then this Karthi will give either 1 or 11. Okay, let's say Karthi give 11. Okay, and this Deepthi will give 2. Okay, now Arun will give something. Okay, 22. Fine. And Anusha has only one thing. Anusha might give, might not give. Okay, it's up to her, up to her partition. Okay, let's say she didn't give anything. Now the output is output is 11 comma 2 comma 22. This is the output because this is a sample, right? Maybe this is your entire data, right? This is your entire data. 1 comma 11 comma 1 comma 2 comma 22 comma 22 comma 22 comma 5. This is your full data, right? Full data. This is your sample data. That's what this sample will do. Okay, that's what this sample will do. Create a sample data set from the original data, right? Now you can do that things on top of that. Okay, joining. Okay, join means, let's say you saw the join, right? um, yesterday, not yesterday, on the SQL class you signed join, right? Join by key. Join on emp dot id is equal to sorry, emp dot department id is equal to department dot department id. We saw this, right? We saw this as on the previous class, right? That was a join. So how join happens is, um, let's say, um, I need to create some data set for you quickly. Okay, sort of join, you can leave it for now because I will do some dedicated class. What happens is, similarly you will have similar partitions. Okay, this is partitions for employee table. Just think in this way. employee table. These are the partitions for employee table, and next these are the partitions for department table. Okay, just think this is not the cut thing, but yeah, employee table and department table. Okay, now what happens is let's say, okay, wait, let me quickly show you. Let me generate small data, show a small example. Okay, simple employee. Small data set. Let's take this data set. So, bus. Yeah. So this is employee a sample employee table. Okay. I'll take this. Let's go to here. Okay. Fine. Now let's go here. Sample department table. Now what happens is, okay. So this is the employee table and department table, right? Okay. This is employee table. Now what happens here is, this finance. Okay. Chicago. Fine. Now what happens here? You will take this data. Okay. I have only 2 persons. Okay. 2 persons to process this data. What happens is, this data will go into one person. Okay. Partition one. Let's say partition one is this data. Partition one of which table? Employee table, right? Hope you guys are following, right? It won't look complex to you. Maybe because uh, it's you already guys aware of this. I was presuming that. Partition two of employee table. This is your partition one and two looks like. Okay. Now let's take this partition as well, department table. Okay. Now let's go with P1 for time sake. Department, right? Department. This two out of this only. Let's take these two things. Okay. Fine. Now P2 of department. Right. This is what it will do. Okay. Fine. Perfect. These are the two partitions. Now, I'm doing that. Select star from table. Sorry, employee table. Okay. Inner join. Department table on. We discuss some key, right? What is that? Um, this is the key. This is the one, right? Join on employee department ID. This is what we on employee.id. Employee.id double equal to department.depend. So what happens is, so I need to make sure that all keys here. What is the key? Department ID is the key, right? Earlier we discussed A, B, C, D example, right? That means this is partition one. Okay, this is partition two. This is partition one, and this is partition two. That means I need to make sure that department key is the key here, right? Department key. Make sure that all department keys, okay, all similar department keys should come and sit into one partition, right? I need to do that, right? You understand, right? I need to do this employee tables join, right? Employee tables join, inner join department table on employee table department id is equal to department or department id. Now what I need to do is I need to make sure that all similar department keys should come and sit into one partition, because right, here one I have, right? Now here I will add this only once one department, once HR and New York, right? I'll just add this here, right? That's what we see. Like, is it correct or wrong? Anyone? So here I'm joining these tables. Okay. If you guys started practicing this SQL, this is very easy. This is very basic. Okay. This is what happens background in the SQL. Okay. So now When I perform the join, when I run this query, now what it will do is, this is what I need to do. This is what it will happen. This is what cluster will try to do. Okay, it needs to group. Okay, group all keys. Okay, all similar keys. That means let's go with department one. Department one. It's a um, department one. Okay. Now what happens is this one HR New York, right? It will come. Okay. Now what are the other partitions with one? These are the partition. This is the row. Okay. That will also come here. Okay. You earlier you said, right? So if you want A, that A is with some other people. That what we just took from that people, right? Similarly, here you will take the two. Okay. Two into one more partition. Partition two. This is partition one. Let's say. Okay. Partition two. Okay. Is there any other two here? Yeah, we have one more two here. Let's copy this two only. Two. Okay. Now I need these two as well, right? These two, because the key department key is two here. Department ID is two here. Okay. We'll just take this into one partition. Okay. Now similarly, department three. I will take this. Take this in part three. Okay. From here, I will take from part three. These are the partitions. Right. Which is all the partitions just take. Fine. Now what happens? What happens? These are the three partitions you got. Perfect. Finally, perfect. Now what happens is the inner join will happen here. Okay. First shuffling happened. Okay. Shuffle happened after shuffling. Okay. After shuffling, data looks like this. After shuffling, data looks like this. This is part one. Okay. Now after inner join will happen here. Now what happens is, so this 103 and 102 records will be joined with this single record. That means it will become like this. Okay. Similarly, it will become like this. Okay. This is the output we are looking for, right? Now similarly, these two record will be taken from here. Let me take this. Okay, it will get joined with join this one record. First 105 record 2 will get joined here. Okay. Now again it will get joined with, it will again go into this record, right? This record will again go and trigger with this function. Okay, that's it. Right. I think we copy duplicate data for 2. This is 2 actually. We will start confusing. This should be the value here. This should be the value here. Okay, so this is how the output looks like. Now for 3, what happens is, first we will take this. Now let's take this 3. That's it, right? This is how data looks like. Okay, maybe bit confusing for you. The final data looks like is, let's take this. This data, once partition calculated this, it will give it to the uh, driver. Okay, driver will take care of these things. This is how final data looks like. Okay, this is how final output looks like. I just did this in front of you, how things works in the background. So there are many mechanisms involved, actually shorting, shuffling, all these things, but on the top level this is how these things works in the background. Okay, any doubts so far? Anyone who understand this at least? Okay, so this,
No doubt.
no doubts, right? This is where we started, right? Sample employee table, right? This is where we started. Sample employee table, sample department table, right? Now from here we did the partitioning. Partition 1 of employee table, partition 2 of employee table, right? We did the partition. Super. Similarly, we did partition for department as well. Like let's say this is partition, because this is not part. It won't be partition 3 because this is the first partition of department, right? And this is second partition of department, right? Now we did the partition. Now what happens? You are doing some application, right? Select a star from employee table where this, and now for your information, how this looks in the real time is, I'm just writing an example. Okay, df underscore employee, okay, dot df underscore other than employee, it's department on. Okay, on condition I need to write, right? On is equal to, let's go with not on. So this condition, right? Let me take this condition. Okay, okay. So this is how it looks in the real time. Why it's not working? Yeah, this is how the condition works like looks like in Spark. Okay, PySpark. Okay, or you can just create these tables. I know it's a bit complex for you, but yeah, let me emp dot create or replace temp u of emp. Okay, this is one view I created on the top of employee table. Okay, now df underscore not df underscore, let's take this name. Okay, so devious underscore department, template view. Okay, let's create depart underscore table. This is employee underscore table. Okay, now what happens is I get in Spark, what Spark provides is spark.sql of. Now this is what takes, and you can just copy this and just put it there. It will work. Okay, so this is also Spark code, every above one. Okay, this is also Spark code and this is also Spark code. Both will work, but here I'm just utilizing spark.sql. Here I'm just going with the PySpark only, plain PySpark. Okay, so this is how it works in the real time, but do not brainstorm on these things. Okay, I just gave you the example how things work, because this is syntax. You need to start working on this syntax once you're good with internet Spark internals. Okay, so that's why. Hope you guys understand this partitioning concept very well. Okay, if so it's very good. If not, just go back to this condition again, or if you're still unable to understand, in YouTube ed there will be some good videos, some animation videos I will say. If I go here, um, grouping in PySpark. Okay, grouping in PySpark with animation. Okay, they will do some grouping. Okay, so they will provide you some grouping and all, so some animation. If I found any animation, I will give you. It really helps you. Okay, so you can just go through that. Okay, that's it. That will be very easy for you. Okay, so you can just go through these concepts. Okay, so now group key join, right? Join, just join. SQL join we discussed. Okay, distinct means remove duplicates in the RDT. So if you have any duplicates, you will remove. If you ask whether for A, she will give only one A. She will remove all of the duplicates. Okay, so collies and repartition means just I will just introduce this topic. That's it. Then we can wind up. Collies means decreases the number of partitions. Now you just saw here, right? How many partitions I have? One, two, three, four, five. Five partitions. Sorry, four partitions. Okay, four partitions. I thought, right? Someone thought to me, right? Okay, let's go with only four. See, only five partitions I have. Sorry, four partitions. Okay, now I wanted to reduce into two partitions. Okay, then I have two options here. I have two options in PySpark. Okay, anyway, I'm going to explain this concept again tomorrow. Partition, and second option is coalesce. Okay, okay, fine. Now, if I wanted to increase the partitions, it was failed definitely. Okay, increase the partition. How many options I will have here? Any idea? How many options I will have here?
Four.
Two directions.
No, actually we have only one option. That is three partition.
Oh,
Okay, coalesce cannot help you to do the increase the number of partitions. Okay, just remember that tomorrow class I will let you know how we will do it. Okay, and for your information, transformation is a spark, right? So this is your narrow. So same partition will be worked with same partition. Okay, same. Okay, but in binary transformation, this data needs to shuffle, right? Shuffle, because this is the partition that Veda got, but she wanted to calculate number of A's. Then what she needs to do? She needs to go and pick some A. This green color, right? This is from this partition, blue is from this partition. Now she needs to pick the values from this partition 2 and partition 3, and she will make single partition, and now she will do its calculation on top of this, right? Similarly, other two persons will do, right? That's what this represents: Y transformation, arrow transformations. Okay, and action, anyway, we will let you know tomorrow. Action means you need to provide your output to someone. Someone needs to either count, collect, first, take, or each, like displaying your data to someone. Okay, or just showing your data to someone, right? That's what action means. Okay, yeah, that's pretty much. Yeah, do you guys have any doubts now so far? That's it. Any doubts, you can just let me know. Yeah.
Not as
Okay, I don't know doubts.
No, sir, could you share PDF to group, sir?
Okay, I forgot, right? Sure, I'll share it. Okay. Veda, Deepti, any doubts?
No, sir.
Okay. Veda?
No, sir.
Okay. His class is a bit fast today. Are you guys okay with this pace?
Okay.
Okay, sir.
Okay, right? Okay. In case you understand, very good. If not, just go through the recording again. Okay. So in that way, you will just keep refreshing these concepts. Okay. These are very important concepts. At first, you will think like you understand that concept, but after some time, you'll forget those concepts. So just try to refresh those concepts again and again. Okay. Fine. If no doubts, then we can wind up.
okay.
Thank you. Thank you all.
Thank you, sir.
Is there
Thank you,
tomorrow?
sir.
Sir?
Yeah. Someone can.
Tomorrow session is there, sir.
Tomorrow it's up to you. I thought like okay, you guys seems to need some time, so that's why I'm not keeping classes on weekend. If you're okay, I will do the classes on weekends as well.
No.
It's up to you. Just let me know in the group.
Yeah, okay, sir. We'll
Oh,
let
okay,
you.
okay.
Okay. Thank you. Thank you. Bye.
Thank you, sir.
Just share the PDF.
Yeah. Sure. 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 Sure.
Okay, thank you.
Thank you.